Let's now deal in this segment with predefined types. That is the types that Julia provide to us as the programmer directly without the need of a third-party package. We have as to start the so-called primitive types that are the most fundamental bricks of the language, because they have simply a fixed number of bits associated to these types, and we already saw them when we saw the type hierarchy. So we have int 64, float 64, char, and so on. All these ones are fixed. They just represented, they just associated with a fixed number of bits. And what is characteristic of this is that even this primitive type, what is characteristic of Julia is that even these primitive types can be defined by the programmer. But we will see this when we will deal with custom types, the segment on custom types. Let's start instead with the char and the strings. We already saw that the double quote is used to define strings, and the single quote is used to define chars. Obviously, a string is made of many chars, and in many ways it behaves like an array. So you can index it with the positions, and if you index with just one position, you have a char, a letter, but you can also index with a range, like in this case where we used the keyword and to define the last element of the array, or in this case of the string, and we have a string, as we can see here. One important characteristic of strings is that they are immutable. So if I type here like this, if I try to change one part and the lower letter I try to put a capital E, I receive an error because I cannot change a string. Like in many languages, a string is immutable. That said, there is one strange thing, that if I call is mutable to a string, I return a true value. This is actually a bug of the language, and there is a long discussion here on this link that I reported here. But aside of this function here, you should think to a string to something that is immutable, that after you define it, you can no longer change it, you cannot modify. There are a set of functions that you can use to get information about your string, like how many letters you have, or to find the first element of something, for example, of a O. You can use this syntax here, and you can even find subsequent letters with this syntax. You can ask if a substring is present in your string with occurs in. Now, why this is false? Because it is case sensitive occurs in. So if you want case insensitive, you can compare your with lowercase both the substring that you are looking for and the strings where you are looking for, and so here you have a true. Now, for 99% of the cases, this is fair enough, it works. Sometimes you have very strange situation where you have Greek letters. With Unicode, really you need to be a specialized of Unicode because it's a very complex standard, and there are corner cases where this may not work. So if you really want to be 100% sure, or you have the possibility that you have some strange letters or symbols in your strings, something that really is you're sure it will work, is to use this fancy syntax, but really no one use this one unless you have some particular case in your program. Finally, comparative concerning information that you may want about your string. You can also have ends with and start with. Guess what? Okay, and you can also use regular expressions. If you know what they are, you can use them as in using R and then the regular expression. In this case, we are asking if our syntax start with H, has a variable number of character, and then ends with D and a space, and here is the case, so we have true. Concerning modifications, we can have a lowercase first, and I let you guess that we have also uppercase and uppercase first. You can split a syntax in multiple, a string in multiple strings, and by default here we use the space, but this is already by default that is used space, but you can split based on whatever string substring you want, and you can replace a word with another in this way. Attention here, so this is called a pair. If I take this expression defines a pair between the first argument and the second one. And with this one, I can strip and remove all the beginning and ending spaces. Concerning concatenation, we have really a lot of different ways to concatenate strings. So the string API of Julia is very powerful, has a lot of methods. We can use this one to join different strings, and we can specify what to use in to join the various strings. We can use this multiplication sign that when applied to string instead of number, it concatenate, it become the concatenator operator. We can also use the function string directly to join multiple strings. Or finally, and we'll see this one better when we'll deal with metaprogramming, we can use interpolation. So with this dollar here, we say put what is in this variable at this point. So here that we composed our hello world by interpolation. Sometimes you want to have some number, but what you have is the number encoded as a string, like in this case, and using parse you can extract the number that is written as a string, and the opposite is obtained by using again the string function. And put attention not to confuse this string function that you used here and here with the lower s with the capital S string that define the type, and the string function, the string capital S, that is the constructor of the string type. This one we will never use it. This is just the type of a string, and the string with lower s is a function that allows this kind of functionality. And finally, as we saw a few of the methods of strings, really there are 400, if I remember, 400 and something. You can access them with methods with. Methods with is nice because it returns all the methods, all the functions that are available to you, where at least one of the argument is the type that you define. So here there are 410 different methods, different functions that support an abstract string. And more in general, you can look the documentation of Julia concerning strings at this URL.